Hi Calculus student, this video is for 5.2 part 3. Still trying to evaluate definite integral. Definite integral is a more general terms of finding area under the curve, but the function does not have to be above the x-axis. So primarily we're just summing rectangles. But if the particular function is the area that formed by this is actually a geometric shape, we can use geometric formula. So I'm going to show you how we can actually find area under the curve, which makes sense. If the area under the curve is like a rectangle or something, or a circle, then you have formula that you can use, right? So I use this space here for this particular questions. Let's bring this down. So evaluate 0, 5, x plus 1 by geometric formula. So integral 0 to 5, the function is x plus 1. We do not want to do Riemann sum dx because we recognize that we graph this. Usually you recognize that you can graph it. How do I graph x plus 1? The y-intercept is 1 and then you rise 1 over 1. So it is kind of like a formula. It's like a straight line like that. And then I want to find the area from 0 to 5. That's how I interpret the definite integral. Is actually the a, b is here, and then this is the function, and this is the area under the curve from 0 to 5. I want to find this area. And you recognize that this is actually a trapezoid, right? So this is the top base, is the bottom base, and this is the height. So the height is 5. The bottom base is what? Is f of 5, right? So we would say f of 5 is what? F of 5 is 5 plus 1 equal to 6. So this length is 6. And then what is f of 0? F of 0 is 1, right? When you plug in 0, it's equal to 1. So your top base is 1. So the area would be, so this would be equal to the area equal to 1/2 top base plus bottom base, 1 plus 6 times height, which is 5, right? This is the height is 5. Because from 0 to 5. So that would be 7 times 5, 35, 35 over 2 for exact value. Okay, so that's how you evaluate definite integral. The second example would be evaluate not by Riemann sum. This is a square root and stuff. There's no integration formula, there's no integer formula that can help you to do this. But if you draw the picture of this integral, -7 to 7, so this would be like that, -7 to 7. But what is this 49 minus x squared? It's actually the half circle of a circle that with the radius 7. Because if you recognize that x squared plus y squared equal to 49 is a circle that has a radius of square root of 49 is 7. So if you solve y would equal to 49 minus x squared square root, which is the upper part of it. So you graph it, it's actually just a circle, right? So you don't need to do Riemann sum. You would just do a circle, half of a circle. So r is equal to 7. So your area is equal to this -7 to 7 of square root of 49 minus x squared. This function is just totally cooked up, so it is a circle. Pi r squared, pi 7 square over 2. Okay, so 49 pi over 2. That is the exact value of this definite integral. What about these? So we have, they make it very technical. They will say this is a function that has 3 parts. Like a absolute value function, the circle, double it, like the bottom half circle, and then another absolute value. And then we want to find integral 8/12 from 8 to 12 f of x. What is 8? 8 is what here? Really? So it's not in the middle. So I'm going to change it to 6 to 12. So it's easy to do because this is 6. 6 to 12. So it's just this big triangle, right? So it's a triangle, area of this triangle. So this part is equal to the triangle. 1/2 base. Base is 12 minus 6 is times 6. What is the height? If I go all the way, it's 3, right? Times 3. So that would equal to 9, right? 18 divided by 2. What about 2 to 5? I need to change this. 2 to 5. What? 2, 4, 5? No, that's also not very good. 2 to 6. It should be 2 to 6. Because we don't want, it is not possible to do geometric formula, right? So 2 to 6 is this half circle, a radius of 2, right? R equal to 2, but it's the bottom below the x-axis, so it's a negative area. So you know that it's signed it. When you do this definite integral, you're allowed to have a negative area. Okay, so it'll be 2 from 2 to 6, so it's half of pi 2 square. So it will be 4, so it will be negative 2 pi. Yeah, negative 2 pi. So this is this particular integral. What about from 0 to 12? So 0 to 12, that means at all this area under or below x-axis bounded by the curve. Okay, from 0 to 12, so you have to add this particular triangle, add this, and add this. So we already calculate this. And then, yeah, I think this is a typo. It should be 6 and 6. Otherwise, we can't do. And then we would do this. This is a small triangle, is 1/2. Base is 2. Height is 1. Plus the one that we just calculate, negative 2 pi. It's a negative. And this one, this big triangle is 9. So it will be 1 plus 9, 10, right? Minus 2 pi. So that is the integral from 0 to 12. You just go from 0 to 2, 2 to 6, 6 to 12 like that. Because we're just talking about area bounded by the x-axis. Is that the end? Let's see. Okay, so we still have properties of integral that we can talk about. Can I finish this? Okay, so we talk about properties of integral. So another way of calculating definite integral is look at the sum of the properties. What are the properties of integrals? Because integral is just area under the curve. So an obvious properties that you have would be if you go integral a to a, that means you actually don't have any basically don't have any area. The area is just from a to a and b are the same, then you don't have area, so it must be 0. Okay, if these two numbers are the same, no matter what function you have, it's 0. And then the other one is if you switch a and b. So originally, if you know what your a, b, f of x is, if you switch from b to a, it's just negative because you're counting backward. Okay, so BA f of x is equal to a negative BAB f of x. The third property is if you have AB add two function, you can split them. It's kind of like what we just did. If you have an area here, and then another function, also do the same area, right? If you add them, then you just add them together. You can, as if you're doing one by one, right? Because you add them, you make it taller, right? So you just do them one by one. Not very nice. Not enough space. So and then if you multiply a constant, it's just kind of like a dilation of the original function. You just move the c outside. It has to do with the limit properties. And then if you have a b f of x, oh, this one is very important. So basically, I think what we have done earlier, it illustrates that. If I want to have, like this is A, and then in the middle is C, and then in the end is B. So the area from A to B can be done by adding from A to C, and then from C to B, right? That makes sense. If you look at area, it's like two pieces of area. you want the whole thing, you add from A to C in the middle, and then C to B. Now this assume that C is in the middle. Even if it's not in the middle, it still works. Okay, even C is outside, it would become a subtraction. It still works. So this is a very good properties for handling definite integral. So let's do some example. You have 0, 8 f of x equal to 10. So someone already did some using Riemann sum or a geometry formula. They know that f of x from 0 to 8 is this, from 0 to 5 is 6. What is 5 to 5 of f of x? Of course, it's 0 because there's no width to it. What is from 5 to 0? That doesn't make sense. Usually we have 0 to 5, right? But how come we have write 5 to 0? That would be this one, right? That would be actually this opposite or the switching backward of this one. So you say negative of 0 to 5 f of x dx. So that means it's negative 6. What about from 5 to 8? Oh, I don't know how to do from 5 to 8. So let's say we can do it as from 5 to 0 first, right? F of x. We have I don't think we should do it that way. We can do from 5 to 0 and then from what? From 0 to x. You see how you just pretend that you go from 5 to 0 first, like a stop, and then from 0 to 8 at f of x. Do we have 0 to 8? Yes, we do have 0 to 8. Do we have 0 to 5? No, we don't have 5 to 0. We have 0 to 5, but 5 to 0 we calculate last, right? It's negative 6. So it'll be negative 6 plus what? 0 to 8 is 10. So that is 4. Okay. There's other way of doing it, but yeah, so this is one way of doing it. And what about if f of x is an odd function? They don't tell us if it's odd or even. But if f of x is an odd function, so for odd functions, they are symmetrical in the origin, right? So this area and this area are supposed to be the same. So if I have a negative 8 and an 8, these two areas is exactly the same, but one is the opposite of each other. So it's just equal to 0, right? But if f is an even function is symmetrical, right? It'll be like that, right? So this area and this area are supposed to be the same. Not necessarily a parabola, but they're just a mirror image of each other. So this would be equal to 2 times of from 0 to 5 f of x, right? From 0 to 5, what was it? Earlier they say from 0 to 5 is 6. So just 2 times of 6 is 2 times of 6 equal to 12. So you can see you can calculate some definite integral by using properties. And these are similar. If I have from 0 to 1, 6x minus 2x squared plus 1/3 x cubed, but I know some of the one that I have, I can just add them. Okay, so I have another part which is average value of a function I need to go over. So maybe I'll just tape another videos for part 4. Is it part 4? To go over this and the average value of a function.